Hello everyone and welcome back to another mini concept, this time about the conservation of mechanical energy. So what is mechanical energy? As the name suggests, it's the energy involved in mechanics or movement. And in these situations, we tackle two different types of mechanical energy. It's potential and kinetic. And these two actually these are what compose mechanical energy as a whole. So in potential energy, there's actually another name for it, which is gravitational potential energy. And this is basically describing potential energy as the energy stored inside an object due to its position, as you can see here. And the formula is given as mgh, where h is the distance from the ground. And this energy from gravitational potential energy, as the name suggests, it has a potential. And it can turn into something new. And what is that new thing? It's actually called kinetic energy. And this is the energy when that object is now finally in motion. So as the object, for example, falls, let's say that it falls, its potential energy turns into kinetic. And it's always going to add up into total mechanical energy. However, before we get to that, let's describe our kinetic energy as 1/2 of the mass times velocity squared. And as I mentioned earlier, these two will always add up to the same total mechanical energy. So for example, let's say that total mechanical energy, we're going to equate it into something. Basically, its formula is going to be total mechanical energy is equal to GPE, which is gravitational potential energy, plus its kinetic energy. And this is true at all times because TME is always constant. It can never be reduced, added to, or destroyed. It is always going to be constant because energy is only ever transformed. So now take into consideration this situation here. We have a 10 kilogram ball on a 10-meter tall ramp, and we're trying to find the potential energy and kinetic energy. So for those at home, you can pause it, but I'll just speed through this really quickly. So let's say that gravity is equal to 10 meters per second squared. We can see and plug these values in to our gravitational potential energy, which is just 1,000. So the unit is joules, 1,000 joules, and this is our total mechanical energy because right now we have no movement. So now let's say that it goes halfway through. We're going to remove half of our potential energy. And where does it go? Is it destroyed? No, it's transformed into kinetic energy. And once it reaches the bottom, it's fully transformed from potential to kinetic. It's maximized its potential. So that means that it's now 0 joules, and our kinetic energy is maximized into 1,000 joules. So this is how total mechanical energy is conserved. This is how it looks like on a ramp. And there are more situations where these are applicable, and we will discuss these more in the next in-depth concepts. So I hope everyone learned something from this, and don't miss the next videos so that we can talk about how mechanical energy and potential and kinetic are related to work and power. So thank you everyone, and goodbye.